daycare addition at Syracuse University, we joined the additional spaces to the existing cafe in section and in plan.
When designing for the daycare, we considered the microclimate analysis we previously analyzed for the cafe and office spaces.
The daycare is accessible through the existing cafe circulation and from the exterior courtyard space. The daycare focuses on incorporating high-performance lighting, ventilation, and acoustics.
For the program, we incorporated a reception, meeting spaces, cubby storage, adult and child bathrooms, kitchen, dining space, activity, and napping space. The daycare has an occupancy of 57 people, and using IBC Chapter 10, we calculated an area requirement of 1,995 square feet. With the daycare program, there is a minimum requirement of 2 exits, which we have spaced at opposite ends of the daycare for accessible egress. The lighting, ventilation, and acoustical elements can be seen in both the sections and renders. We have called out the lighting elements such as the fixtures and skylights, as well as the acoustical elements such as the fabric and wood panels. We highlighted their relation to the individual program in the renders seen in the hallway space and exterior.
The lighting for the program has a minimum requirement of 300 lux according to the U.S. General Services Administration Child Care Center Design Guide. The lighting resembles a residential environment to make the children feel comfortable. Climate consultant data shows that the natural lighting in Syracuse is not sufficient for the program to fully rely on it. We chose dimmable pendant lights to allow for the individual comfort of the lighting conditions for different activities like napping. The specific light fixtures we chose is called Ondaria 2 LED. Instead of fluorescent lights, we used LED lights because they are more efficient and last longer. While the main source of light is natural light from the skylights and the clerestory windows for the summer sun, these pendant lights help illuminate the spaces in the winter months. The southern facade is made up of glass to allow in lower sun angles during the winter. The acoustic wood panels also direct sunlight from the skylight above. Using this information, DIVA simulation shows that the play area to have a luminance that ranges from 250 to 500 lux at around 3 p.m. in the winter. Hello?
We calculated the required airflow by using section 6.2.2.1 breathing zone outdoor airflow and found that it was approximately 809.4 cubic feet per minute. Comparing this with the climate consultant data, we see that the ideal months for natural ventilation are June, July, and August. Other months are too harsh to rely on natural ventilation. Using the CBE thermal comfort tool for July, we tested to see if natural ventilation was a viable option for the space. We used the metabolic rate of 1 to 2 since the children's activity levels range between sleeping and running. We then selected the limited clothing option since it's summer and a low airspeed of 0.1 meters per second for the microclimate. Using these parameters, we found that Syracuse does not comply with ASHRAE 55 because the temperature and humidity are too low. Due to these results, we cannot solely use a natural ventilation system, but we can use it to supplement the mechanical HVAC systems. We used the Echophon acoustic calculator to get an accurate depiction of the acoustical performance of our project. In the results, with Sabine and RAC calculations, we reached the Echophon recommended value for speech clarity and strength, but not for reverberation time. However, our results for reverberation only slightly go over the Echophon recommendations, and the calculations do not take into account the full extent of our acoustical system.
Addressing the acoustics of the space, we used a variety of panels and textures to help mitigate sound from the children playing. On the floor, we used an absorbing foam padding, which works by dampening the sound of children running. There is also small-scale wood furniture scattered throughout the room, which helps reverberate sound into the space. The wood panels on the ceiling and the walls also dull the sound along with the felt panels. The wooden panels serve as a dual purpose, simultaneously working to better the sound of the space and to diffuse the direct lighting coming in from the skylight. The napping alcoves placed at the edge of this play space is padded with cushion to absorb sound from the interior and to pad the thick retaining wall that blocks the sound from the exterior. Finally, the enclosed courtyard creates visual and acoustic privacy from the foot and vehicle traffic for the children utilizing the extended retaining wall.